Can y'all hear me good? Yes, no? First off, cool. If any of y'all can't see the screen real well, I've got a link to all of these slides up in the corner. Just so if you can't see, then you can at least get to it on your own machine. So I am here to talk about important things about JavaScript that no one bothered to tell you. A bit of background. At my company, I am in the QA department, but we are using Angular to write the program that we are selling, and I figured this would be a good thing for me to learn. So I went online, started looking through tutorials, run through Tour of Heroes, which I'm sure some of y'all have seen, and what I found is that there's a lot of information out there. There's, as I said, tutorials, there's technical documentation, blogs, people write articles about specific issues that they've had. There's all this stuff. The problem that I was running into is that you can't ask questions of a video on YouTube. If somebody says something that you don't quite understand, even if it's something that somebody could explain in a second, it just turns into this huge headache of having to dig into what were they talking about and having to research that on your own. So basically, that's kind of why I'm here, is to go over some of those things that maybe people just assume that their audience knows. Because as I say, authors will assume that you have a certain level of proficiency, and if you don't, then there will be things that they just gloss over, and then you're just completely lost for the rest of their talk. The third point is that, as I say, information can get stale very quickly. So even if somebody has asked a similar question to what you have on Stack Overflow or some similar resource, if the answer is 6 months old, it's entirely possible that it is no longer relevant at all. So basically, I'm going to be talking about a bunch of things which were potential problems when I was learning this. Maybe some of y'all have run into the same sort of things. These are going to be synchronous versus asynchronous programming, using functions as parameters, callbacks, arrow notation, promises, and observables. So a lot to go through. If you have questions, please hold them until the end and then ask somebody who knows more than I do. So the first item is synchronous versus asynchronous programming. When I started, the language du jour was C, where everything was pretty much synchronous. And basically, the big difference between synchronous and asynchronous programming is that when you have a synchronous program, you can read through the code just top to bottom and say, okay, I see what's going to happen in what order. Subject, of course, to looping, branching, those sorts of constructs. In asynchronous programming, it's more an issue of things are going to happen in an order based on how long it takes the code to execute. So as an example of this, we've got a tiny little thing that I wrote here, and please work. Stop. Okay. So you can see here that I've just got a few lines here. On line 8, I say add the word first to the screen. On line 13, I say add the word second. But when I run this, the word second shows up first because it took the code longer to reach the line where the word first gets added. And that's the sort of thing that I'm referring to. If you just try to read this top to bottom, you could just be completely lost as to why that happened. So many things in modern JavaScript tools and libraries are asynchronous. Exactly which ones are or are not is beyond the scope of this talk, but understanding that this can happen and be occurring is going to be something that's helpful, just so when you get results that don't make sense, you'll say, maybe this is what's going on. The next item is functions as parameters. In JavaScript, functions are objects, and they can be sent as parameters to other functions. And this gets used all over the place. So as an example of this, you can see here that I have the set timeout function. The second parameter to this is just the number 1000. The first parameter is this entire other function that's in red. And as I say, this is widely used, so being able to understand this programming construct and being able to follow this is going to be very helpful to you. This third point is kind of the combination of the previous two. When I was talking about synchronous programming, when you have a function call, when that function returns, it goes back to the point in the code where it was called from. In asynchronous programming, that's not necessarily going to be the case. So if you have to tell your asynchronous code what to do next, you have the idea of what's called a callback, which, as I say here, is a function that is sent as a parameter to an asynchronous function, which will allow passing of control to the function that you passed in. So in my example here, the set timeout is your asynchronous function. It does its thing for 1,000 milliseconds, and then when it's done, it calls this function that got sent in. And incidentally, that's what was going on in the previous example that I had showed. Now, what if you're saying, oh, you have the word function in there. That's a long word, and I'm lazy, and I don't want to type that all the time. The JavaScript architects have your back. They have introduced what's called arrow notation, which is an alternate syntax for functions which are being passed as parameters. It's, as I say, slightly less verbose. It makes it a little easier to concentrate on the functionality of the code and what's going on. So here you can see that I've got two examples. Like I've got an array of ice cream flavors, and then I'm running this for each loop, just that's running through each item in that list. And in the left example, using function notation, you can see that for each actually takes a function to do whatever it's doing. But you might want to more concentrate on what's actually going on and not having to be thinking in the back of your mind, this is actually a function I'm passing in. And that's what you get over here on the right, where you just say, okay, my flavor and index are available within this loop, so I can do whatever I have to do. One thing to keep in mind is that there is a difference between these two, and that is that within the function that gets called, the value of the this variable will be different depending on whether you're using the function notation or the arrow notation. So that's just something to watch out for. And now you might be thinking, when you were showing functions that got sent into other functions, you have this indentation. What if you have a lot of callbacks? Won't you get this huge tree that's hard to read? And the answer is yes. So one thing that's been developed to help alleviate that is promises. These are a somewhat cleaner method of handling asynchronous operations than having a bunch of callbacks. A promise is always going to resolve exactly once. It will either be fulfilled and then all of your operations are done and you get your object sent back or whatever you want to do, or it will be rejected, which basically means you had some sort of error condition. The nice thing about promises is that they can be chained together using this then keyword. And this lets you write code that is asynchronous that looks synchronous. So in this example, you can see that I've got these three functions that might be the part of I'm trying to put my ice cream together. You've got a function to get a cone, a flavor, your topping, and each one of these is going to be asynchronous. Maybe they've got the cones on hand, maybe they need to go get it from a box. So you don't know exactly how long they're going to take, but you know they have to happen in order. If you try to put your ice cream in before you've got your cone in hand, you're going to have a problem. So if you look at where this is actually called, it's very easy to read. You get your cone, then your flavor, then your topping, and now you have your ice cream. So even though this is asynchronous code, it reads top to bottom like it was synchronous. But what if you're saying, Phil, I'm greedy. Your example there only lets you put in one scoop of ice cream. What if I want more? Then you might use what's called an observable. This is something that's similar to promises in where you're going to use them. The big difference that I've found is that observables can fire more than once. So in the example here, I'm creating an observable based on a button that gets clicked. So if we come back here, come back to main, stop, run. So here I try to add a scoop of vanilla. I know I get some vanilla. If I want one of these, each time I'm clicking that button, that is the observable firing and adding to my data structure. So that's what's going on there. So lastly, I have a list of several resources that I had found while researching this. And these are things that I'd found to be useful. So the end result of all this is that going through and learning all of these things, while none of these are specifically, here is something that is directly applicable to Angular, it's a good foundation, and learning these things I think is going to be very helpful to me and probably also very helpful to you.